Imagine if every memory you've ever made, your first day of school, the taste of your favorite food, the name of the person you love, were suddenly gone. What would be left of you? Today, we're diving into one of the most remarkable abilities of the human brain: the power to transform fleeting moments into memories that last a lifetime. And the science behind it is far more extraordinary than you think. Welcome to the hidden world of long-term memory formation. Memory is not just a function of the brain. It is the architecture of our identity. From the moment you wake up and recognize your surroundings to the moment you drift into dreams filled with yesterday's reflections, memory is the thread that weaves together your entire existence. Without it, there would be no sense of self, no understanding of the world, and no continuity between the person you were yesterday and the one you hope to become tomorrow. But what is memory really? And how does the brain transform moments, fragile, fleeting, and quickly forgotten, into something that can last a lifetime? To answer this, we must take a journey deep into the brain's neural landscape through billions of cells and trillions of connections, where the very essence of learning and memory is etched into the biological fabric of who we are. Every memory begins as raw sensation. The flash of a passing car, the warmth of sunlight on your skin, the sound of someone calling your name, all of these impressions enter something called sensory memory. This stage lasts only a fraction of a second. It's like a camera shutter rapidly clicking through the world, capturing everything but keeping almost nothing. Yet something remarkable happens when you pay attention. Focus acts like a spotlight. It selects, prioritizes, and elevates certain details above others. The moment your attention locks onto an experience, it transitions into short-term memory, or what scientists call working memory. This is the conscious stage, where your mind temporarily holds information in a mental workspace you can actively manipulate. But working memory is fragile too. Try memorizing a phone number while someone interrupts you. It's gone almost instantly. This is because working memory is not where long-term memories are stored. It is simply the doorway. To pass through that doorway and enter long-term storage, the brain must undergo a deep and complex transformation, one that involves the reshaping of physical neural connections. Deep in the center of your brain lies the hippocampus, one of the most important structures for memory formation. Shaped like a curled seahorse, it acts as a master librarian whose job is to sort, categorize, and prepare memories for long-term storage. But here's the fascinating part: the hippocampus does not store memories. Instead, it orchestrates them. Imagine the hippocampus as a command center, constantly communicating with countless regions of your brain. When, and only when, the hippocampus decides that an experience is important enough, it begins the process of consolidation. This process isn't about writing data into a single folder like a computer. It's about building a vast network of connections linking sounds, sights, emotions, and physical sensations into one unified memory that can be retrieved later. To form long-term memories, the brain relies on one of the most well-studied processes in neuroscience: long-term potentiation, or LTP. LTP is the strengthening of communication between neurons. Think of neurons as friends who grow closer the more they talk. With every interaction, their relationship deepens. Their communication becomes faster, stronger, and more automatic. When you learn something new or experience something meaningful, neurons fire together repeatedly. Over time, the synapses between them physically change. They grow stronger, releasing chemicals more efficiently and becoming more responsive. New receptor sites are created. Entire neural circuits reorganize themselves. This is not metaphorical. It is literal. Your brain physically changes with every memory you make. This is why the famous neuroscientific phrase rings so true: neurons that fire together, wire together, and this wiring is the foundation of long-term memory. While you rest, your brain becomes more active than you might imagine. During deep sleep, particularly in slow-wave stages, the hippocampus begins replaying patterns from the day, almost like watching a highlight reel of important moments. It's during this nightly replay that the brain asks itself, what mattered? What needs to be stored? What should be forgotten? This is memory consolidation in action. The hippocampus essentially teaches the cortex, your brain's outer layer, what to remember. Over time, memories gradually migrate from the hippocampus into the cortex, where they become more stable and less vulnerable to fading. This is why sleep deprivation can dramatically reduce your ability to remember new information. Your brain simply doesn't get the chance to perform its nightly memory upload. Now, long-term memories are not all created equal. The brain uses different pathways to store different types of information. First, we have explicit memories. These include facts, stories, events, and knowledge you consciously recall, like your birthday or the capital of your country. Explicit memories rely heavily on the hippocampus and the cortex. Then we have implicit memories. These are unconscious and automatic. They include habits, skills, and emotional responses. Things like riding a bike, typing without looking, or feeling anxious when you hear a dangerous sound. These memories use entirely different brain systems, such as the basal ganglia and cerebellum. This is why people with hippocampal damage can still learn new skills, even if they can't recall ever learning them. Emotion is one of the strongest forces shaping what we remember. When something hits us emotionally, whether through joy, fear, excitement, or sadness, the amygdala becomes deeply involved. The amygdala acts like an alarm bell, signaling the brain, "This matters. Store it. Store it deeply." This is why emotional moments become so vivid and long-lasting. Why some memories feel almost impossible to forget. Why a traumatic event may haunt you, or a joyful moment may uplift you years later. Emotion strengthens memory formation, but it can also distort it. We often think of memory as a perfect recording of the past. But in truth, memory is incredibly fragile and flexible. Every time you recall a memory, it becomes malleable again, like soft clay. Your brain rewrites it slightly based on your current emotions, new knowledge, or beliefs. Then it stores the updated version again through a process called reconsolidation. This means your memories are not static snapshots. They are living narratives, constantly evolving. It's the reason eyewitness testimonies can be unreliable. It's the reason people remember shared events differently. It's the reason our past changes with us as we grow. This imperfection is not a flaw. It is part of the brain's brilliance, because memory is designed not just to preserve the past, but to help us navigate the future. When you look at a photograph from years ago and feel a rush of familiarity, that moment is more than an image. It is a testament to the extraordinary power of the human brain. A long-term memory can survive decades. It can endure the birth and death of cells. It is passed from one neural circuit to another like a story carried through time. And when you learn something new or experience something meaningful today, your brain begins constructing yet another memory, another connection, another thread woven into the tapestry of who you are. Long-term memory is not just science, it is humanity. It is the reason you can grow, adapt, dream, understand, and become someone new every minute of your life. Your brain is writing the story of you. Thanks for watching. If you found this journey into the mind as fascinating as we did, be sure to subscribe and hit that notification bell so you don't miss our next deep dive. See you in the next video.